If you're gearing up for that certified safety professional exam, then you are in exactly the right place. Today, we're diving deep and mastering one of the most important topics you're going to face: thermal stress. So here's our game plan. We're going to start by making sure you can recognize the telltale signs of both heat and cold-related illnesses. Then we'll get our hands dirty with the calculations you absolutely have to know. After that, we'll cover the controls that actually work, and we'll wrap it all up with a rapid-fire checklist for exam day. Ready? Let's jump right in.
So first things first, why is this such a big deal? Well, this isn't just about making sure people are comfortable. This is a fundamental part of your duty as a safety professional.
This quote right here, this is the legal bedrock. Managing thermal stress isn't just a good idea. It's a legal obligation under OSHA's General Duty Clause. This is the clause that says employers must protect their people from recognized hazards. And for your exam, you need to remember that thermal stress falls squarely under Section 5A1.
Okay, this is a classic exam question, so listen up. You have to know the difference between stress and strain. Think of it like this. Heat stress is the external hazard. It's the heat from the environment plus the heat your body generates from working. Heat strain, on the other hand, is the body's internal reaction to that load. Put it simply, stress is the cause, strain is the effect. You've got to get this one right.
So how does that heat strain actually show up in a person? Well, that brings us to recognizing the hazard. And knowing these signs isn't just good to know, it's an absolutely non-negotiable skill for a safety pro.
You know, heat illness isn't usually a sudden thing. It's a dangerous progression, a kind of slippery slope. As you can see here, it might start with something that seems minor, like a heat rash, but it can quickly get worse, leading to cramps or even fainting. If you don't intervene, it can escalate into the really serious stages: heat exhaustion, and ultimately the life-threatening one, heat stroke. Catching it early in this chain is everything.
So if there is one thing you need to be able to distinguish, it's the difference between heat exhaustion and heat stroke. This is literally life or death. With heat exhaustion, the body is still fighting. It's still trying to cool itself down, so you'll see a lot of sweating. But with heat stroke, the body's thermostat has failed. It's given up. The skin goes hot and dry. The core temperature shoots past 104 degrees, and you start seeing major neurological signs like confusion. Heat stroke is a full-blown, sirens blaring, medical emergency.
Recognizing symptoms is vital, but as a future CSP, you have to be able to quantify the risk. You have to put a number on it. And that brings us to the calculations, specifically the wet bulb globe temperature, or WBGT.
Now, the WBGT isn't your regular temperature reading from the evening news. It's the gold standard for a reason. It masterfully blends 4 key things into one powerful number: the air temperature, humidity, radiant heat, from the sun or hot machinery, and even air movement. It gives you the complete picture of the heat load on a person.
For the exam, you've got to know 2 formulas. Here's the first one. This is for when you're indoors or outside without any direct sun. It's pretty simple. It's 70% from the natural wet bulb temperature, which is all about the potential for evaporative cooling, and 30% from the globe temperature, which accounts for that radiant heat.
Now, what happens when you step out into the sun? We have to add one more piece to the puzzle: the regular dry bulb air temperature. But look closely at how the weightings change. That wet bulb is still the king at 70%, but the globe temp's influence drops to 20% to make room for that dry bulb at 10%. You're definitely going to want to memorize both of these formulas.
I'm going to say this again because it is that important. 70%. That's how much the natural wet bulb temperature matters in both formulas. Why is it the big kahuna? Because our body's #1 way of cooling down is sweating, evaporation, and the wet bulb is the best measure of how effectively that sweat can actually evaporate and do its job. If you only remember one thing about WBGT, make it the overwhelming power of the wet bulb.
Okay, so we've identified the signs, we've quantified the hazard. Now what do we do about it? Let's talk about implementing controls, specifically 2 of the most critical ones you'll be tested on: acclimatization and hydration. First up is acclimatization. This is the body's amazing ability to adapt to heat over time. For a new worker, this isn't optional, it's mandatory. The standard protocol, as you see here, is to ease them into it. Start with just 20% of their full workload on day 1, and then ramp it up by another 20% each day. This 5-day schedule is a really key and very testable concept.
And just as important, if not more so, is hydration. The guideline is super clear and specific. Workers need to be drinking 5 to 7 ounces of cool water every 15 to 20 minutes. And notice, it's not drink when you're thirsty, By then, it's too late. It has to be a strict schedule because preventing dehydration is your first line of defense against every single heat-related illness.
Now, of course, we've been focused on heat, but thermal stress cuts both ways. The CSP exam is absolutely going to expect you to know about the other side of the coin, the hazards of cold environments.
So when we talk cold, there are 4 big injuries you need to have on your radar. You've got non-freezing injuries like chilblains and trench foot, which happen from being in cold, wet conditions for too long. Then you've got the big systemic one, hypothermia, where the entire body's core temperature drops to dangerous levels. And finally, you have frostbite, which is the actual freezing of your skin and tissues.
So what's the best way to protect against the cold? It's all about this 3-layer system. It's brilliant in its simplicity. The inner layer gets sweat away from your skin. The middle layer, think wool or fleece, is your insulator. It traps heat. And that outer layer is your shell, protecting you from the wind and rain. Each layer has a specific job, and when they work together, they keep you warm and, just as importantly, dry.
All right, we have covered a ton of ground. Let's wrap it all up with a final checklist. Think of this as your high-yield, must-know last-minute cram sheet for the big day.
Let's go. 1. Heat stroke is a true medical emergency. 2. Full acclimatization is a process. It takes about 7 to 14 days. 3. The natural wet bulb is the absolute heavyweight champion in the WBGT calculation. And 4. Evaporation through sweat is the body's #1 way to cool off. Got it? Good.
Okay, a few more. Lock these numbers in. Hypothermia kicks in when that core body temp drops below 95 degrees Fahrenheit. Frostbite happens when tissue actually freezes, so that's below 32 degrees. But don't forget trench foot. That can happen in cool, wet conditions all the way up to 60 degrees. And finally, know the physiology. Your blood vessels vasodilate, get wider to release heat, and they vasoconstrict, get narrower to save heat.
So, what's the ultimate point of all of this? Here it is. The reason we do all these calculations and memorize these facts is to figure out safe work-rest cycles. And you can't do that with just half the story. You have to combine the environmental heat load, that's our WBGT, with the worker's metabolic rate, which is the heat they're generating from the job itself. Putting those 2 pieces together is how you turn numbers into actions that protect people.
And really, that's what this all comes down to. These aren't just abstract formulas and facts for an exam. These are the tools that you will use to assess a real hazard, to put controls in place, and ultimately to prevent a tragedy. So the real question isn't just what you know, it's how are you going to use these tools to protect a life.